G'day guys, we've got a calculus question for you today where it's asking us to determine the gradient function of a quadratic using the definition of a derivative. Now, sometimes the questions might interchange definition of a derivative with first principles or something of that nature, but today we're just going to stick with the definition of a derivative. Now, if I was asked for this particular question in an exam, what I'd first do, just to try and sort of solidify myself in the question, try and maybe pick up a mark here or there, is I would tell the teacher or tell the examiner what the definition of a derivative actually is. So let's start with that then. So for the general sense, if we have a function y equals f of x, its derivative y dash will be equal to the limit as h tends to 0 of the function at x plus h minus the function at x all divided by h. Cool. So what we've got here is this is the scaffold that we're going to use to solve the question. Okay, so what we now do is we're going to substitute the function that we've been given into the general case. So our function is y equals 4x squared. So our derivative y prime is going to be equal to the limit as h tends to 0 of the function at x plus h. Now what that means is we get the structure of our function, but where we see an x, we substitute in x plus h. So let's do that. We have 4, and rather than x, we're going to have x plus h. We're going to square it, like that is. Then I'm going to minus just the regular plain vanilla function, 4x squared. I'm then going to divide it all by h. And now I have my function substituted into the general definition of a derivative. Alright, so far so good. So now what we're going to do, there are a few steps that if you follow these, they're exactly the same every time you do a problem like this, and if you get good at it, you shouldn't have any problems under any kind of exam situations. So the first step is we're going to multiply out any brackets that we see. So let's try that. Here is our bracket, so we still write in our is equal to the limit as h approaches 0, but we're going to multiply out this bracket. So to start with, we're going to multiply out the quadratic. We're going to have x squared plus 2xh plus h squared. We then just will have our plain vanilla function on the end. And the second step to multiplying out this bracket is to then multiply the 4 into the bracket. So let's do that. Great. So you can see inside our big square brackets, we don't have any more brackets. They've been effectively multiplied out. Step 2 is we're going to combine our like terms. Now in this particular example, there is only one set of like terms, and that's the 4x squared part. So let's just go and combine them. We have a positive 4x squared and a negative 4x squared. So if we combine those two together, they're going to cancel each other out and effectively equal 0. So let's just get rid of them. Cool, so that's the second step taken care of. The third step is we have to do something with this h in the denominator. The reason we have to do something with the h in the denominator is because if we take this limit and evaluate this entire function as h approaches 0, the function is going to approach infinity, which is not going to be any good to us at all because the denominator will approach 0. So the way that we deal with the h in the denominator is we factorise the numerator by h. Now this should always work. So we have the limit as h approaches 0, and we're going to factorise the numerator here, or what's left of the numerator, by h. So that's going to be 8x, and that's going to just be plus 4h, all divided by h. Now, because we've multiplying that h by whatever's in the bracket, and then dividing by h, these two will now cancel out. And we leave ourselves with the limit as h tends to 0 of 8x plus 4h. Cool. Now, just a little side note. At each point in our working out, we have written the limit as h approaches 0. It may seem tedious when you're doing it at home, when you're trying to practice these, but get into the habit of writing the limit as h approaches 0 in front of each of your steps. And the reason for that is in your exam, if you get a question like this and you forget to write the limit as h approaches 0 on all of these steps, you're going to lose most of your marks. The teacher's going to say, yeah, he's got his steps right and he knows how to solve it, monkey see, monkey do style, but he doesn't know what he's talking about, or she doesn't know what he's talking about. So write the limit, because after this step, we then have to evaluate the limit. And the way that I like to evaluate the limit is just write a sentence or a limit statement. So my statement for this, I'm going to write as h approaches 0. So that's evaluating the limit. 8x plus 4h approaches. Now, if h approaches 0, 4h is also going to approach 0. So 8x plus 4h will be equivalent to 8x plus 0, or just 8x. Finally, we can then say, therefore, the derivative, y dash, is equal to 8x. Cool. So let's go through the steps one more time. First of all, in an exam situation, not one similar to this where there is no pressure, in an exam situation when you're under time pressure and this question may only be worth a couple of marks, you'll be rushing and stuff like that, I like to write this statement on the top. I like to define what this definition of a derivative is first. The reason I like to do that is if I cook up the algebra in the second step, the teacher is going to go, he knows what the definition of a derivative is. So that makes the teacher more confident or feel better about giving me a mark for that. I know what the definition of a derivative is, I just don't know how to do the algebra that a 12-year-old should know. So the next step is I then substituted the problem that they gave into the general case that I've written down first. And then I get to there. Now, if the mark scheme is similar to the way that we do it in Australia, you'll probably get a mark for that too. What I then did is my algebra all the way to the derivative is 3 steps. The first step is get rid of the brackets. The second step is get rid of the h in the denominator. And then the third step is evaluate the limit. So after I evaluate the limit, I write my limiting statement, or my limit statement, as h approaches 0, 8x plus 4h approaches 8x. And therefore, the derivative is 8x. So, I hope the video helped, guys. If it did, throw a like my way, subscribe to my channel, I put out new videos almost every day. But until next time, I'll see you later.